Right, so this is the third false start for this video, so keep my fingers crossed, it will be good. So, welcome back. Romtech, as I've gotten in their good books apparently, decided to lend me these two beauties right here for a review. And I spent quite a lot of time actually going through their performance and details and operation and everything that I could think of. I've put them through a fair number of tests, some of which we'll actually see in this video. And sadly, my impressions were increasingly grim. I've seen a lot of raving reviews about these two instruments, and I can see why. But I wholeheartedly disagree with quite a lot of them. And I'll explain why in a few minutes, but first of all, let me just give you a quick overview about these two instruments right here, and then we'll get into the nitty gritty. So the DMM 7510 is a 7.5 digit multimeter. It is technically 7.5 digits, you can see them, and it does give you 7.5 digit readings, but I'm not sure it's actually 7.5 digit capable in respect with noise and linearity and other stuff like that when it comes to performance. Apologies for the cables sticking out in front of you. Also very fun that you can see both the WD-40 and my couple $100 worth of soldering equipment on top of thousands upon thousands of euros worth of high-end test gear. So going back to the 7510, I don't know what Keithley wanted to get done when they did this meter. It's built as a very high-speed sampling DMM, so it's got like insane sample rate for voltage and current, but only 4.5 digits, and it's got up to a megasample per second of sample rate or something like that. It's crazy fast. But guess what that megasample per second sample rate gives you? It necessitates a high bandwidth input, which means that a high bandwidth input designed not particularly well or down to price or not up to a specific standard will be quite noisy. And this is one of the things that I've noticed about this DMM. It's actually pretty noisy. The second thing that I'm honestly kind of disappointed about with this meter is that they stuck to their guns with the recessed banana connectors, and worst of all, they're not even copper or something low thermal EMF. They're, I think, nickel coated or something terminals, because when I tested the input noise spectral density of the meter, I'll insert a graphic here, I saw a giant thermal equalization thing when I plugged in the short, and then it leveled out. Still pretty noisy, but yeah. I did a number of other tests with it, including measuring the linearity of the 2450, so I used this to measure the linearity of this, and it turns out that this source meter isn't very linear when it changes ranges, which was unsurprising, but I didn't expect it to be that bad. I can't really measure the linearity of this one because my Kelvin Varley is still a bit in the works, but I did measure the stability and it was pretty good. I think it's got an LT flu inside or something like that. Speaking of LT flu, it does have ACAL. I wonder where we've seen this before. And you can see that it wasn't performed because, yeah, I wasn't interested in the absolute readings, more in the variation and the noise and the stability of the reading. So I compared this with my 3458A, of course. That one let's put it this way. This meter is 4,600 euros. You can't get a 3458A for that money. You can, however, sometimes find a second-hand one for about the same amount of money, and oh boy, this can't hold the candle to that meter by any stretch of the imagination. So, TLDR, if you want just my very quick overview and you're not going to watch past the 5-minute mark, I wouldn't get this with my own money because it's not the meter I want. And I'm probably not the target market for this meter, but yeah. Let me tell you a few more things about this meter. So first of all, it's got the same interface as most of the 2400 graphics 2450 series graphical user interface devices have. It's got front rear switch. Funnily enough, this one's an actual hard switch, and this one is a button and a relay. Go figure. It's got this wheel, which I found absolutely useless, completely useless. I found it even more useless on the source meter, because if I want to go and source something, for example, I can change the source range relatively easily, but then I have to go and edit this digit by digit, which is kind of stupid. I don't know, I would think that once you got into here, you wouldn't want to change individual digits. Oh, and it's also very sensitive to accidental presses. So see, I tried to rotate it and it just changed something instead of, it just clicked instead of rotating. So I don't like this. I don't know why they put it. I used to have a 6500 and it didn't have the wheel, and I never once felt the need for an encoder knob on at least on a digital multimeter. Like, what are you gonna do? It's not a calibrator. It's not. I wouldn't need that. The buttons are also very gummy and kind of not really pleasant. There's I worked with a 2460, I think so, source meter, which had a terrible output enabled button. Like, you had to press it until the entire rubber cap receded behind the front panel in order for it to register. So I think that was a manufacturing defect. This thing, they slapped in basically a Linux computer in front of this thing, and I think they kind of compromised on the actual performance of the meter itself. And as you can see, it can program scripts. I think the flowchart programming model is almost Turing complete. I'm not entirely sure. I think this could competently run Doom. I'm not going to try it. And yeah, it can pretend to be... One of the things that I really love about this thing is that I think it can pretend to be a 3458A in readings, but I don't remember exactly how to do that. So yeah, this is for backwards compatibility, but I don't know who would ever buy one of these to replace a 3458A. I mean, okay, it's got, I think, a couple of million, no, a couple 100,000 readings capable to store in its buffer. It's got a USB on the front panel, which crashes the instrument if you plug anything bigger than a 16 gig USB stick in it. I would actually show this to you, but I think nobody's gonna ever give me anything to review ever again. It can do histograms, it can do graphs. Let me tell you, they have this thing called Smart Scale. It's anything but smart. And I will try and show you an example, but the thing is that when you just start to, let's clear the buffer and look at the graph, And you can see it's kind of trying to act like an oscilloscope, and it's focusing on a pretty small portion of the input, like of the data, and it's just moving the data along. I don't know, I usually prefer to have it with no smart scaling and to tracking all the readings. Okay, more about the user interface. It runs fine on GPIB, it runs fine on Ethernet. I've never had any issues with that. I love the Keithley virtual front panel. I found it very useful while this thing sat and measured my 731B voltage standard for a couple of days. One thing that absolutely shocked me was that by default, when the instrument, and this being a 7.5 class digit multimeter, boots up, is that it goes into this weird, almost like a digitizer reading mode. And if you go to settings, so first of all, there's quick set, which is this slider, and it adjusts between resolution and speed, and it claims to have a maximum of 4 readings per second at 7.5 digits. Okay, let's say that we believe it, but then let's go to actual settings, and we see that we're only integrating over 5 power line cycles, and the line sync is off. Like, what the hell is this, man? I don't like this. So it's not synchronizing the readings with the power line cycle itself, which I'm pretty sure I lost the data for that, but because I immediately discarded it as untrustworthy, but it gave rise to extremely noisy measurements. And another thing that I really do not like is that the maximum power line cycle integration that you can go to is 12. So you can only get 12 power line cycles, multiply that by 50 milliseconds per power line cycle, so you get around 6.6 seconds for a reading, which, yeah. It measures all the requisite things like capacitance and continuity and diode, but I would never use this as a like a general troubleshooting meter. I would much rather prefer my, and it's, to my mind, the impression that I had using this meter was that they didn't really know what this thing wanted to be. So, okay, it's a very good digitizer, but then why make it be able to read 7.5 digits if you're gonna compromise the input noise performance in order to get the requisite bandwidth? If you wanted to get a 7.5 digit multimeter, like, I would have been happy with not very many readings per second, but with the ability to have more than 12 PLC integration time for readings. And again, anytime you do something, it's very hard to, it's kind of counterintuitive. Like, I get it that they put a very nice user interface and the touchscreen is decently responsive and it's decently bright and it's under very harsh lighting right now, but anyway. And the other thing that they claim that this thing is very good for is measuring sleep current for IoT devices and stuff like that. Well, granted, sure, it can do that very competently. It's got a pretty good burden voltage, it's got very good resolution and sample rate, but not at the same time. And you can't expect this thing to have 100 decibels of dynamic range or something like that, so you can measure on the same scale both the sleep and the wake-up current and stuff like that. I've tried it. It never really worked for me. You need to get a device that's exactly like running in that specific range between, like if we go to DC current and we go to the ranges, you can see that ranges are 10 micro, 100 micro, etc., etc. And you have, for example, in the 10 milliamp range, you have a resolution of, if we go to something more reasonable, so this is 1 microamp, 1 nanoamp. Well, yeah, sure, I wouldn't trust those final digits, and it's only 10 milliamps, and you go tell me of a device that can competently function with nanoamp sleep currents and 10 milliamp run currents. And if you want to go to a higher range, then you lose resolution, and if you want more sample rate, then you lose an increasing number of digits. So this is nothing like what Keysight have with the device current waveform analyzer. That's a far better suited device for the purpose to measure IoT current draw than this is. Okay, it's 10 times more expensive, but if you're designing a, I don't know, something like if Xiaomi are designing the next smart home monitoring sensor that needs to last 10 years on a battery and use LoRa to transmit or something like that, they're not going to use one of these. Even Keithley themselves have those precision power supplies that I'm going to insert the models here somewhere, that have very good capability for measuring current draw from a device, and that thing has almost as good of a meter inside as this thing. It's 6.5 digits, but I would trust that those 6.5 digits are about as same level of 6.5 digits as this is a 7.5 digit meter. I don't know if that was very clear, but what I meant to say was that the performance of the two meters are very equivalent, and the pricings of them are very equivalent, which means that you're ditching the ability to measure a lot of things, but you're also getting a very, very, very nice power supply. Okay, I've made enough fun of this thing. I'm going to let future me talk you through some of the readings that I've done and describe a few of the results that I've obtained from this device. I'm not going to do any demonstrations because I think that all the demonstrations Keithley has on, well, Tektronix have on their website regarding this product are slightly misleading, and the one that upset me the most was a comparison between 6.5, 7.5, and 8.5 digit multimeter when it comes to noise, and somehow this one trumped them all. Well, yeah, you know, marketing. Don't get me wrong, it's a very nice meter. I'm really happy to have played around with it, but again, it seems to me that this meter doesn't really know what it wants to be. It's not sure where it wants to be a digitizer, it's not sure where it wants to be a 7.5 digit meter. Like, it's supposed to be replacing the 2001, but I'm pretty sure that you can still buy the 2001. It's almost 2 times more expensive than this one. The 2002, which is the 8.5 digit meter that Keithley has, is about the same price as a brand new 3458A, and that one is known to be considerably worse in linearity and noise than a 3458A. So I don't get where this meter is priced at. So they have a very good digitizing meter, which is the 6500, which is a quarter of the price of this thing, and I'm pretty sure that the only things you're paying the difference in money, which is about 3,500 euros, are the extra digit of resolution, which I don't see necessary in such a device, the knob, and the higher stability voltage reference in there. So yeah, so these are my thoughts about this meter. Like, I'm sorry if I'm upsetting anybody. I'm not sure if I could come up with any demonstration that would explain my point of view more clearly than what future me is going to talk you through in a few minutes. But that's about everything that I have to say about this thing. I know it's not pleasant or nice, but this is the only way that I can ensure that I'm at least being honest. I try to be as honest as possible in the 2 series oscilloscope review, and I'll try to be as serious as possible and as honest as possible in this one. So this is about it for the 7510. Let me set up some things and we can take a look at the 2450 and what we can do with something like that. Be right back. Right, so now that we're done making fun of the 7510, let's take just a couple of minutes and let me walk you through some of the main selling points of this 2450. So this is the baby model in their SMU line. It's meant to replace the 2400, I think. The 2400, the good old 20 watt SMU from back in the day. It shocked the world by replacing the, in my opinion, irreplaceable 236. 2410 replaced the 237, which I have, the 1 kilovolt model, etc. And they had various other source meters. I think only Keithley can call them source meters because they copyrighted the term. Other manufacturers have to call them source measure units. Whoa. So this is a 20 watt source meter up to 200 volts, plus or minus 200 volts, plus or minus 100 milliamps. It can go, I think, 20 volts at 1 amp. I'm not entirely sure. I think so. And I've never tried it. I'll get to why in just a second. And it's got pretty decent specs for current measurement and stuff like that. It's got triaxial connectors on the back. It's got a decently low noise front end, though it's not spectacular. I would say that my 237 is lower noise than this thing is, and it's, let's see, quick set, source voltage measure current, and we're sourcing 0, and we're in idle. Let's put it in continuous, and it's got a 10 nanoamp range. The lowest one is 10 nanoamps, which gives it a resolution of, like, again, this one is even worse because the power line cycles only goes up to 10, and you gain an extra digit. So this is 1 picoamp, 100 femtoamps, so you get 10 femtoamps of resolution, which is, I think, the same as my 237. That's only 5.5 digits, but it's got a 1 nanoamp current range. So front end's pretty comparable, although I think, again, disclaimer, I'm not very good at this, but I think the 237 is a bit less noisy than this is. This thing has a LM399 voltage reference in there, galvanized Zener. It's got that fancy isolated power supply inside with the coaxial transformer. I'm gonna link in the EUV blog thread about the thing. These two units actually have very good leakage current to mains, which is impressive. Actually, it's very good, and they do that not by using a fancy power supply, but they have a isolated power supply stage inside with a very fancy transformer made of triaxial cable and stuff like that. It's a can of worms. So what can you do with this thing? I think I got sidetracked, and Grandpa Simpson, like, I'm learning a lot from Grandpa Simpson when it comes to parallels. What can you do with this thing apart from sourcing and measuring stuff at the same time? This is a 4-quadrant power supply. It's got the ability to both sink and source current, so it can measure, it can characterize semiconductor devices, material science. You can do electrochemistry with it. I tried to do that, but I didn't have any interesting electrochemical experiments to hand, so tough luck, I guess. But we can do some more general electrical measurements, not general electrical measurements, and we can look at a diode and stuff like that. The unit itself, as stated previously, has the same touchscreen interface, the same knob, which is equally useless in my opinion for this device as well. Decent current resolution, decent voltage resolution, right? It's a fully featured instrument. It's much better than the 2400. At least this one has a triaxial cable and it's got very good electrometer performance, but it's not an actual electrometer. Okay, so what can you use it for? Well, contrary to popular belief, you can actually use it for measuring a lot of things first of all. So if we go to, QuickSet and set it up as a voltmeter, and it will give us a warning. Hey, the input can have very high voltages present on it. Well, no, if you're gonna measure high voltages with it, it will have high voltages on it. And another funny thing that happened a few days ago, and why I wouldn't recommend using this thing as a power supply for anything that consumes more than like 10 milliamps, is that I got the funniest error message. I'm gonna try and reproduce it and show you what it looks like. It popped up with a nice window saying, "The heatsink has reached 65 degrees C temperature. Please consider corrective action." Like, what? Okay, so what I have here, and I'm not gonna be able to tip it up so you can see. Oh, maybe you can see it. This is a Weston cell. And Weston cells are basically they were the gold standard voltage reference for a very, very long time. And up to 1980 something, when they invented the Josephson junction. And so this was basically the gold standard, the highest stability voltage standard there were. And it's got this very weird 1.018 volt output at the regular 23 degrees temperature. This one is actually from 1968, the one that I have here, and you can see that it's very, very close to what it's supposed to be. Now, what can you do with this thing? Well, considering the fact that I said that it's got a very good electrometer-like front end, if we go and set it to more resolution, 1.0815 is exactly what the reading should be, 17, etc. And we can see that we're only drawing 500 something femtoamps from this Weston cell in order to measure it, which is good because these are not batteries. They're not meant to store a lot of electrochemical charge that you can just connect to any good old 10 megohm input impedance digital multimeter and just measure them all the time, because you would entirely ruin them very quickly. So what we're doing, and what this can also pretty competently do, if we go to measure voltage, and sorry for jumping between them like this, but I have to show you this. This also has a very, very good high impedance input. Let's see. Auto is usually, I think it's in the order of gigohms. So what we're doing is that we're using the electrometer-like input of the source meter in order to draw as small a current as possible in order to get the voltage reading from the Weston cell. So you can use it as a electrometric voltmeter, and you can do very sensitive measurements, like you can measure very high impedance voltage sources like internal charge pumps in semiconductors, electrochemical cells, and stuff like that. So that's one advantage of having a very high input impedance. Now, when it comes to high input impedance, we usually think of electrometry as a whole. So is this thing an electrometer? Well, not really. Otherwise, Keithley would have discontinued the 6517. So this is not an actual electrometer, but it can, in a pinch, serve as a pretty capable one. So if you'll excuse me for just another second, I'm going to prepare another experiment. So what I have connected here is a 100 gigaohm Victorine glass encapsulated high value resistor. This is taken out of something I found at the flea market, and I always wanted to have a good excuse to use it in a video. And I have cleaned it thoroughly with isopropyl alcohol, and I have tested it against my 617, and it's pretty much bang on 100 gigohms. So let's go and do something, and we'll go to source, and we're going to source voltage and measure resistance. Source voltage and measure resistance. And express. Okay, of course you can't. Jesus Christ. This sort of some stupid warnings. It just notified me that it cannot measure resistance while it's not sourcing any voltage. Well, duh. Alright, I'm gonna hit it with 100 volts, and we shall see what happens with the resistance value. I have no idea what it's doing. What's going on? Okay, this is the worst interface that I've ever seen officially. So we're in source voltage and measure resistance, measure current in ohms, and we'll turn it on. And apparently it's got a problem with this. I've never seen this happen. I think this is an actual bug. Okay, let's do something else then. Let's go and generate a sweep, because I also wanted to try and show you this. So we'll go from let's start at negative 100 volts. I hate this thing. And we'll go to 100 volts, and we'll step it from 1 volt at a time, because otherwise it's going to take a very long time. And I generated a configuration, and let's see if that will work. So what is going on? Interlock is enabled. Okay, apparently it just refuses to do anything now. Hold on, I'll fix this. By the way, this thing is also pretty loud. I don't really like it that much. It's not as loud as my 3458, but this thing is considerably quieter. Considerably more quiet. Okay, so we go back to sweep. Start from negative 100. Go to 100. And why am I trying to do it like that? You'll see. Generate. Not best fix. Auto range. I think that was a problem. And we shall go to, oh, I forgot. Source voltage and measure resistance. And let's go to graph. And let's trigger the reading. Okay, it's doing it. and it will take a very long time. I'll just leave the camera running and try and fast forward this. Alright, so this is going to take far too long to show. But what I wanted to do is show you the voltage coefficient of resistance for this resistor. Okay, so I'm then going to try and replace it with a smaller value resistor. Let's go for, I think this is a 10 mega ohm resistor. It's going to be let's try it out. Right, so this was far too fast and you did it far too quickly, but you can see it's pretty good, 10 mega ohms. Here you kind of see the effect that I wanted to show you, but the interesting part is when it gets close to 0 volts and it doesn't have any bias, it's pretty, at least to me, it's pretty funny that it, even if you give it a lot more steps, let me try it. The graph still looks absolutely horrible because it's auto-ranging kind of poorly, and I think that because it's doing that, it doesn't have enough resolution. So let's start from -10 to do the math properly. So -10 volts up to 10 volts. And let's generate this again. Let's go to graph and trigger that again. So I let it run once and I'll try and look for the data for it. I don't think I have it anymore. And it did the same weird zero crossing thing and flipped around. And yeah, it's not really good at doing the math around 0 or with very large variations of voltages like that. Actually, voltage and currents. Alright, let me show you another kind of weird thing that I found about this thing. So this is the hollow cathode lamp that I had, that I showed in the previous live stream. So we'll go to source voltage, measure current, and we'll just ask it to source us a nice cool 210 volts. Source voltage, measure current, okay, and source 200 volts. Settings conflict. I think it learned that I don't really like it, and it's trying to make me look dumb. Finally. And we'll give it the most 8 milliamps because that's what the tube can handle. And now it doesn't even light up anymore. Let's go to negative. Finally. This used to work a lot better a couple of days ago. I don't know why. So what is happening now is that it's trying to comply with what the vacuum tube, the lamp wants, and it's thinking about, it's sourcing actually, about 8 milliamps at 100 volts. Now, why the thing happened previously, first of all, despite the fact that the range selected was auto, when I hit compliant, when I asked it for 200 volts, it for some reason didn't want to change the range so it would fit. I don't know, that might be a bug. I don't know what firmware version these things are running. It might be due for an update. And that current limiting that you saw again with the what do you call it, the yellow font, I don't know what that was about. The next experiment that I had for you was actually trying to show you the ignition characteristics for this, but apparently I won't be able to do that. So let's look for a neon bulb. Just a second. I think I might be able to use one of these here. So if we connect the terminals like this, hope you see what I'm doing, one of the neon bulbs is going to light up. Doesn't really matter which one. Hopefully you're going to see it. And now let's go and source let's set another sweep up, but first of all let's set another function. So we're going to go to sweep and start at negative 100 microamps and stop at 100 microamps. Why? Because, well, you'll see. And we're going to step by 1 microamp every time. And source limit 210 volts. And generate. And let's go to graph and trigger that. Okay. And you saw that happening, and I don't know what happened. Oh, it's far too fast. Let's give it some more. Okay, let's try it like that. Oops. It's doing some very weird noises when the switching converter sounds kind of weird inside. And we should see the arc extinguish. I just realized I'm dumb. See? Source current and measure voltage. And let's try that again. I don't know if you can hear the sound it makes, but it's making a very sound. And you can, if you keep a close eye on the electrode, you can see that it's actually igniting first one of the electrodes inside and the other. By the way, this sound, the sound, is nothing that I've ever heard before in a source measure unit. And I'm not sure what's going on. Right. Anyway, so we have sort of ignition characteristics for one of these things. Let's do something more interesting, and let's do a tunnel diode. I'll be right back. That's sure to be interesting. So I have a fresh tunnel diode, especially just for you guys, and I am going to go back into the sweep generation and change the limit to 5 volts and regenerate it. I'm not gonna touch the pulse thing on this thing. It beats me. Okay, now we go to graph and we trigger it. And we wait. As I said, it's pretty slow compared to my 237. I don't know why. I think it's just the fact that it's a bit more noisy, and the 237 could have done the same measurements a bit faster due to requiring literally less integration time. You know? And we should see it go into... If it oscillates, I'll be with egg on my face again because... yeah. I'm not sure what it's doing. Oh, I forgot. Okay, so we need a new diode. We direct bias the diode, I think. So let's start at 0. Okay, regenerate this. I hope it's this way. And graph, trigger. My 4145 semiconductor parameter analyzer was completely capable of seeing this through, and my 237 was also very adequate for measuring this tunnel diode. Although I will raise some conflicts in the comments, I think, considering the fact that you're not measuring the actual characteristics of the tunnel diode, you're measuring one of the infinite characteristics that it can have, because it's oscillating in that region where it's doing the tunnely thing. Let's try that one more time. Actually, no, let's stop that and let's go to more current. 1 milliamps and 10 microamp steps. And generate and menu graph trigger. Yeah, that looks more like it. And I think we busted the diode again. What the hell is going on with this instrument? I think it hates me. I really think it does. I had such a low opinion about its brother that it just refuses to cooperate with me anymore. Let's do this another way. Finally. Right, so apparently when you set it to characterize it as a diode by sourcing current, it doesn't really work. So this is the slope, this part here is the negative differential resistance part of the tunnel diode. And now it's gonna limit back to 105 microamps. But yeah, that's pretty much what I was expecting. Okay, so I did have one more thing that I wanted to show you. And let's take a look at that. So I'm gonna have to edit a lot of this video out. So what I have here is a pretty small solar panel, right, which is being lit up right now by my studio lights. Let's generate another sweep and let's start at 2.1 volts because I know the values. Hopefully it's gonna work. It might have changed a bit, and go to 0 and let's see what happens. And let's go to 10 milliamps maximum, but it's gonna be and let's go to 100 millivolts and generate. And menu graph, not this, not the histogram data, and trigger. Whoops, wrong polarity. I'm just going to switch these around here. let's do something quick before. What I'm trying to do is show you the maximum power point of the solar cell. So yeah, it should be pretty good. So let's start at 2 volts. Oops. Quick set source voltage, measure current, and generate the sweep again. Start at 2 volts and go to 0 volts and step from 0.1 volts. Okay, and limit at 10 milliamps and source delay and range, auto ranging, generate, and menu graph trigger. Right, so it displays it the wrong way around, but you get the point. So at 0 volts basically, so at short circuit, we have a peak of 640 microamps. And if we, to cite a dear friend, if we exercise some restraint, we can get as much as 600-ish microamps, but at 1.8 volts. So this is how you'd characterize the maximum power point of one of these solar cells. And this is the open circuit voltage here going up to, like, it's not, we're not hitting its open circuit voltage yet because the current isn't going positive. So if the current was going positive, it meant that we were feeding power into the solar cell, which is not good. Okay, so I would like to show you a diode, but I really don't think that's gonna be useful anymore. Hopefully by seeing me struggle with this thing, you can see that it's got quite a number of bugs. Let me just make it crash for you guys. So this is a 256 gig USB stick. And it says fatal system error, instrument has encountered a fatal unrecoverable error. And it's not this one only, it's this one too. So both of them crash with the same thing. So this was happened with any USB stick larger than 16 gigs that I've had. And if you cycle the power to them, they're gonna be fine. Let me just show you how long it takes for them to boot up. Yeah, so an hour of mocking 2 otherwise very interesting and nice devices, but my opinions are pretty mixed about these things. On one hand, I really like them. They're very nice, not that nice to use, probably because I'm too poor to afford new gear. And on the other hand, they're kind of, at least this one is kind of undecided. I get this, where this is going more, but this DMM just seems to be quite undecided. So apologies if you expected something more optimistic. Again, I'm not one to, like, I don't get any financial incentives to review this gear, so I just do it as honestly as I can. If I had any financial incentive, I would have said that, oh, this is almost as good as a 3458A at half the price, which it clearly isn't. It's barely better than a 34401 or 465 or whatever. I wouldn't classify it as a 7.5 digit multimeter, and being as confused as it is about what it wants to be, it's quite, I don't really like it. This one is pretty nice. I think it's far more powerful if you use it with, computer and program it and make it do automation and testing. But if you're gonna get, like, let's say 4 of these and setup, a sort of semiconductor parameter analysis setup, you might as well just get a Keithley 4200 and have far more configurability. So I don't know who these two are aimed at. Probably these aren't really meant for the kind of semiconductor characterization that I'm used to. I don't know if they're ever used in production environments. They might be. The only place I've ever seen them being used till now was to measure the current draw of an IC and add different voltages and just, at least not what it's supposed to be doing. So, or measure some breakdown voltages or stuff like that. So I'm pretty confused about how this thing is confused, how badly confused this thing is. Just goes to show my level of confusion. I'm slightly less confused about this one, and I appreciate the fact that they at least put triax connectors, but it's also very snarky, very snarky. So if you go to, okay, let me make it do it again. Source voltage, measure current, performance, and okay, and let's, okay, and or no wait, you have to go the other way around. Source current and measure voltage, 10 nanoamps, and oh, they finally got rid of that thing. Or at least I can't make it do it again. Maybe? It used to tell you, hey, consider using the triax connectors on the back because your measurement might be sensitive. Well, duh. But, it's just, I don't know. Maybe they're aimed for education. I have no idea. So, in order to alleviate any further confusion that my review might cause, I would say this: if I had the money, I would have bought that Tektronix 2 series. I mean it. On condition that I only had to buy something new. If I had the money to buy these things, and the caveat was that I had to buy something new, I don't know if I would buy these. I still have yet to see and take a look at what the Agilent source meters are, or the Rohde & Schwarz source meters are like. I heard that the Rohde & Schwarz ones are a bit worse, like even noisier. I know Rohde & Schwarz don't make a 7.5 digit multimeter. I know that Agilent, Keysight, make a killer multimeter. So this is out of the question in that respect, but I think the B series source meters, source measure units, sorry, because Keysight don't have the trademark. I think the B series source measure units from Keysight might be a bit better, less noisy. I have no idea. Anyway, if anyone wants to lend me one of those for review, I'll happily try it out. Okay, so let's put it this way. This is the best new source meter that I've ever played with. Asterisk, not including the 237 because that's not new, although I far prefer that one. This is an mediocre multimeter. It's a good digitizing multimeter. It's a good data acquisition system. It's a decent general purpose bench multimeter solely because it costs so much. Like, it would be far better if it were 6.5 digits and cheaper. So if, like, for bench multimeter, I would use the 6500 all day long, and for metrology grade, this is nowhere near close. So I don't know what they were thinking when they designed this one. This I kind of like, this I don't really like, and I shall be giving them back to Romtech and not feel very sad to not have them around anymore, because I'm not really missing anything. So it's been more than an hour, And yeah, I don't want to take up any more of your time. I'm going to try and put some chapters in the video, and that's about it. So if you stuck around for this long, thank you very much. I appreciate you watching it, and have a great day. Bye.